Assalamualaikum, my dear friend. Today we will talk about Minterm, Maxterm, sum of product, product of sum, subjective normal form, disjunctive normal form. We will discuss one by one friend. So first we start from the literal. The word literal means the Boolean variable or its complement is called literal. What is Minterm? The Boolean variable is a product of n literal in which each variable appears exactly once in either it is true or complement form, but not both. So the list of all minterms of two variables, then we consider the variable x and y. So we applying this formula to raised to the power n, which is equals to raised to the power 2. It means it has four variables, four values. So list of all minterms of two variable x and y, then we consider these are the four values xy, x complement y, x into y complement, x complement into y complement. Minterm means when the two variable is in product form. The list of all minterms of three variables x, y, z. Then we consider the variable x, y, z, x complement y, z, x into y complement into z, x, y into z complement. X and y both are complemented with z. X and z both are complemented with y. Y and z both are complemented with x. And all variable x and y, x, y, z are complemented. So it is the list of minterms in two variable and three variables. Now we will discuss the next point. What is Maxterm? The Boolean n variable is a sum of n literals in which each variable appears exactly one in either true or complemented, but not both. So list of all Maxterm. Maxterm means when the variables are it is in addition form. So in two variables x and y, and we are applying this formula to raise to the power n. It means when we consider two variables, so it has four values in Maxterm. So x plus y, x complement plus y, x plus y complement, x complement plus y complement. Then we consider the list of all Maxterm in three variables. Then we consider the variables x, y, and z. So the Maxterm values are x, y, z, x plus y plus z, x complement plus y plus z, x plus y complement plus z, x plus y plus z complement, x complement plus y complement plus z, x complement plus y plus z complement, x plus y plus y complement plus z complement, x complement plus y complement plus z complement. Because it has three variables, so there are 8 values in Maxterm. Now first we write an application about the minterms. Show that the minterm expansion in two variables x and y is identically equal to 1. So when we consider the first method, it is algebraical method. So we consider, it means the question is xy plus x complement into y plus x into y complement plus x complement y complement, which is equals to 1. So we consider here left hand side, student. If you see that the second term and the fourth term, it may be some common values. It means x complement is a common value. So we will consider x complement and y plus y complement as it is. And then we consider the first and the third term. X is common. So the common value is x, y plus y complement. We write here. So in the next step, student, as you know that y plus y complement, which is equals to 1 according to Commonness law. So x dot 1 it is x, and x complement into y plus y complement, which is equals to 1. So according to law, x complement x plus x complement, which is equals to 1. So x complement into 1 it is x. So x plus x complement again, which is equals to 1. So left hand side is equals to right hand side. But when we do the next term, Minterm identically equals to 0, then we put here. Now the second method, then we consider x Minterms identically equals to 1. So here we consider if we take in the value of x is 1 and y is 0. So it means the complement of x, it means the complement of y, 1 is 0. Or when we consider the variable y, the complement of 0 it is 1. So first we take in left hand side, then we put here the value of x and y. X is 1, y is 0. The complement of x is 1, the complement of 1, y is 0. X is 1, the complement of y it is 0, 0 complement, plus x complement, it means 1 complement, and y complement it is 0 complement. So when we put here is 1 dot 0 it is 0, the complement of 1 it is 0, so 0 dot 0 it is 0, the 0 complement it is 1, 1 dot 1 it is 1, and 0 complement it is 1, 1 complement it is 0, so 0 dot 1 it is 0. Then we add all these values, the answer it is 1, so left hand side is equals to right hand side, hence proof. Now write an application about the Maxterm. Show that the Maxterm expansion into variable x and y is identically equals to 0. So when we consider the method according to Boolean algebra, what is x? If we consider x is 1, y is 0, so the complement of x is, that means 1 complement, it is 0. And when we consider the complement of y, it is 0 complement, it is 1. So first we consider the left hand side. X plus y, it means 1 plus 0. X complement, it is 1 complement plus 0. X plus y complement, it means 0 complement. X complement plus y complement, it means 1 complement plus 0 complement. The next step is 1 plus 0 it is 1. 1 complement it means 0. 0 plus 0 it means 0. 1 plus 0 complement it means 0 complement it is 1. 1 plus 1 it is 2. It is 1. According to Boolean algebra, 1 plus 1 equals to 1 we write here. And 1 complement it is 0 or 0 complement it is 1. So 1 plus 0 it is 1. So when we multiplying together, the answer it is 0. So left hand side is equals to right hand side, hence proof. After the addition, is sum. What is sum of product form? Represented by SOP. A Boolean expression capital E represented by capital A is said to be in a sum of product form if E is a sum of two or more product of variables, like as, for example, x, y, z, x complement y, z plus x, y, z complement. So this form is called SOP. It means sum of product. Now what is product of sum form? POS in short form. A Boolean expression is said to be in a product of sum form if E consists of several sum terms logically multiplied. Sum of term logically multiplied. But the first definition shows here a sum of product form, it means sum of two or more products, sum of two more product of variables. So when we consider the three variables, so x plus y plus z, they consist of several sums, term logically multiplied. It means when we consider, for example, x plus y plus z complement, it is both are multiplying together, and the next term it is x complement plus y complement plus z into, it is product form. So it means the Boolean expression consists of several terms, some terms. It means these variables considered here shows that they are adding then product. It means multiplying by the next expression. So this is called product of form, sum of product. So now student will consider disjunctive normal form represented by in short form DNF. A degree and Boolean function small f is a unique sum of minterms of the variable. Conjunctive normal form represented by CNF. A degree and Boolean function f is a unique product of Maxterm of the variables. So these are the definition about the CNF and DNF. And the unique sum of minterms of variable is called disjunctive normal form, and a unique product of Maxterms of the variable is called CNF. It means conjunctive normal. So now we write an application about the Boolean product. So the first application, find a Boolean product of the Boolean variable x, y, and z that has the value 1 if and only if you have given three conditions. X, y both are 0, z is 1, x is equals to 0 and z is equals to 0, but y is 1. X is 0, y and z both are equals to 1. So now if we find the Boolean product, then we consider 1. So student, as we know that x and y both are 0, so it means when we take in the complement of both variable, which is equals to 1, which is equals to 1, value of 1. So it means when if we compare this value, it will be converted into 1. So the complement of y and complement of x is equals to 1. So the Boolean product is x and y complement, but z as it is because it has 1. So this is called the Boolean product when three variable. Now the second condition is x and z both are 0. So we will take in the complement of both. So it means it is equals to 1. So x complement, z complement, and y as it is because it has 1. So x complement y into z complement, it is in the second part. Now here student, in the third part, y, z both are equals to 1, but x is 0. So only we will take the complement of x only. So the Boolean product is x complement, it means 0 complement, which is equals to 1. So the answer is the Boolean product is x complement, y and z both are similar, the same. So these are the application about Boolean product. Now the next application about this trend, if you find a Boolean sum either x or x bar, y or y bar, z or z bar that has the value of 0. When if you find a Boolean sum, you consider 0. If you find a Boolean product, you will consider 1 only. So in the first part, they have given the value of x and z both are equals to 1, but y is 0. X, y is equals to 0, but z is equals to 1. In the third part, x, y, z all are equals to 1. So if any term, if it has y, it has 0, it means it cannot be changed. But if the variable, it will be in 1, so we will take the complement. So since x equals to z is equals to 1, so then we will take the complement of both elements. It means one complement which is 0, and we take in the complement of constant one complement which is equals to 0. So it means the Boolean sum is sum represent here the addition sign. So we will write here x plus z, x complement plus z complement, y is as it is because it has 0. So the Boolean sum is x complement plus z complement plus y as it is because it has 0 element. Since in the second part x and y both are equals to 0, it means we will convert this term into 0. So we will take a complement of z only. So since z is equals to 1, so then the complement of z it is 0. So the answer it is, when we write the Boolean sum, it is in this form x plus y plus z complement. Now the third part, x, y, z all equals to 1, but when we convert into 0, it means we will take the complement of each element. So as you know that x, y, z both are equals to, all are equals to 1, so then we will take each element taking the complement. So x complement, y complement, z complement, it means the complement of 1 which is equals to 0. So the answer it is the Boolean sum we write in this form x complement plus y complement plus z complement. Now the next application is when if you learn about the Boolean sum, how can we find it? Find the SOP expansion of the Boolean function. So if we have the first part of the question, if you find the Boolean sum, the function you have given x plus y plus z in the first part A. The rule is follow when we find the solution, take the Boolean sum of the min terms where the function evaluated to 1. So first we make a table student because it has 3 variables, so we will take in each column 8 values. In the first column 4 times 0 and 4 times 1. In the second column 2 times 0, 2 times 1 and repeated, it is in repeated form. And in the third column alternate number 0, 1, 0, 1 in 4 times. If we add all variables according to the given condition, if f of x, y, z which is equals to x plus y plus z, if we added all variables value, the answer it is 1, 1, 1. So evaluated to 1 means when we consider z is 1, it means it has not changed, but when y and x both are 0, it will be changed into 1. So it means we will take the complement of both element x complement, y complement, z as it is because it has 1. Similarly, the second, y is 1, but x and z both are 0, so we will take the complement of both elements x complement, y, z complement. So we write here the sign, the third term, it means x, y and z both are equals to 1. When we compare this value, it means we will complement only the variable x. So x complement y or z as it is. Listen, when we consider the fifth value, it means 1. So the answer it is Z is similar, X is similar, but Y will take the complement. So it means plus 4th, 5th value. It means X complement, X as it is, Y and Z both complement for the 5th term, or when we consider the 6th term, it means X and Z both are equals to 1. So 0, it means we will take the complement of Y only. So X, Y complement Z. It is right here. So the next term it is there are 5 terms. Now the 6th term it is 1, 1, 0. It means we will take in the complement of Z only. So X, Y as it is, the complement of Z we consider here, and in the last value it is all or same, because when we compare this value to all these values, so it means it has no change, X, Y, Z. This will be our answer because it has 7 ones, so we will consider, count them 1, 2, 3, 4, 5, 6, 7. So there are 7 terms. So these are called disjunctive normal form. Then we evaluate the midterms to evaluate it to 1 and take the Boolean sum. So this is called Boolean sum, and we consider the midterm. Now the next application is when f of x, y, z is equals to x plus y into z. It means first we will make 3 columns. The 4th column it is, then we add it together. It means second and first column if we add, we will make the column. And the last one is when we multiplying together 3rd and 4th column, then the answer is in this form. So take the Boolean sum of the minterms where the function evaluated to 1. It means when in the last column where 1 is lying, so we will consider these terms only with the help of x, y, z, because 1 is similar to z, 1 is similar to y, but it is different. So we will take the complement of x. The complement of x, y, z are similar because it is 1, and we compare. Similarly, this value is compared to x and z, both are similar, but y is different. So we will take the complement of y only, and in the last term it is 1. Then we consider it will be 1, 1, 1. All values are similar to 1. So plus x, y, z. So there are 3 minterms in this function. So we'll find out easily. So student, we consider here, find the Boolean sum, then we consider the minterms of the function, Boolean function. Now the next one is now the third part of the minterms, f of x, y, z, which is equals to y. First we make 3 columns. After that, we will consider only which is equals to y. It means whole function which is equals to y. So we will consider this column where y represent here. Take the Boolean sum of the minterms where the function is evaluated to 1. So it means there are 4 ones in the y column. So it means we take the complement of x because y and z both are similar. So x complement yz. Then y is 1, but x and z both are 0. It means we will take the complement of x and z, y is as it is. Similarly, for the next, when we consider y is 1, so it means all variables values it has 1, so x, y, z are as it is. And in the last, so it means when we consider 1 for this variable, so it means when we consider y, because we consider y only, so it means z is complemented because it has 0, x and y as it is. So this will be your answer. It has 4 minterms with the help of Boolean algebra. Find the product of the sum of expansion each of the Boolean function in part A, x plus y minus z, x plus y into z, z complement. First we make 3 columns according to these values, or according to given conditions, and first we add second and first column, then negative sign, it means x plus y minus z, it means first we add and subtract from z, it means 1 minus z is 0, 1 minus 0 it is 1, 1 minus 1 it is 0. So we will make the last column, it means the fifth column, with the help of x plus y minus z. So if you find the Boolean product of the Maxterm, we evaluate the function to 0. So it means there are 4 zeros rise. So it means the against of 0, x, y, z all. So we will write the CNF, it means conjunctive normal form. Maxterm we write in the addition form. So x complement, y complement and z, because all are opposite to 0. All are, but here x and z both are opposite to this function. So we will take the complement, x complement plus y complement, y plus z complement, because y is 0. And we evaluate 0 to x, y, z, because they are against. So we will take the complement, x as it is, x plus y plus z complement, and the last one is 0. So it means when we evaluate, all values are similar from 0. So x plus y plus z as it is. It has no change. So the next application is when we find the Boolean product and the function f of x, y, z, x plus y into z. We will make 3 columns. Then first we will determine x plus y, it means we added both columns, and multiplying by z for the next column, it means fifth column, and find the answer. After finding the answer, we will consider only if you find the Boolean product of the Maxterm, the function evaluated to 0. So it means we will consider zeros. It has, in the last column, it has 5 zeros. So when we compare this 0, the value of the variable of x, y, z, it means it is similar, but they are opposite. So we will take the complement, both of them, x complement plus y complement plus z as it is. Or when we find the complement, then both are similar, only x is against. So we will take the complement of x plus y plus z as it is. And the last 3 values, if we take, then we consider z is similar to 0, both are 0. So it means we will take the complement of y only, because x and z both are similar. So x plus y complement plus z, and the second last value it is z is against, but x and y both are considered as 0. So it means x plus y plus z complement, and the last term all variables value x, y, z both are similar to 0. That means it has no change, x plus y plus z. Now the next application about if you find f of x, y, z which is equals to z complement, for example, first we will make 3 columns x, y, z. Then you take the complement of z of the third column of each value, you take the complement, and after that, if you find the Boolean product of the maxterm, so the function evaluated to 0. So it means we consider the 0. Each value, each variable x, y, z value, it has against of 0. So it means we will take complement, x complement plus y complement plus z. Here, x and z both are complement, both are against of 0. So we will take the complement. Y as it is, x complement plus y plus z complement. And when we consider x, the function value is 0, but y and z, they are against of 0. So we will take the complement of y and z, x is as it is. So x plus y complement plus z complement into the last value. When we consider z is 1, but x and y both are 0, it is similar to the value of the function. So we will take the complement z only and x plus y plus z complement. So these are called conjunctive normal form. So there are 4 zeros and we write here 4 maxterm values in terms of conjunctive normal form. So thank you very much, student. I hope you will learn about the lecture today. Thank you so much. I have completed my lecture. Thank you very much. God bless you. Take care.